This time, ladies and gentlemen, we're going to be talking about the seasons. What actually causes the change in seasons? It's quite dramatic that you can go from temperatures that are in the 90s to temperatures that can be minus 30 to 40 degrees Fahrenheit. That's quite a huge swing in temperature for our little planet. But what actually makes that happen? Now, this is something that is misunderstood by a lot of people. There was a study done a handful of years back at one of the Ivy League schools, and when I say Ivy League, we're talking Harvard, Cambridge, one of those out on the East Coast, and they did kind of an exit survey or people who are graduating, and about 90% of them did not know for sure what caused the seasons. So when you're done here, you can feel extra smart because you're going to know something that a lot of people get wrong. The quick answer of what causes the seasons is the tilt of the Earth's axis relative to the plane of the ecliptic. Now, what is not true, and we're going to spend a lot of time explaining this in a moment, what is not true is that the seasons are caused by the distance from the Earth to the sun. Many people, this is the most common answer, and it is the wrong answer, is that we are close to the sun in the summer and we are further from the sun in the winter. As a matter of fact, for those of us in the northern hemisphere, this is exactly reversed. Our orbit is quite circular. It's very circular, but it has a little bit of a oblong or elliptical shape. But it's not a huge enough change in distance to account for this heating and cooling. So it goes back to this tilt of the Earth's axis, and this is how this works. If you can picture the sun and then each one of the planets as it goes around the sun, and that this sort of looks like a phonograph record, an old-fashioned record. If you looked at it from the side, there's the sun, and there's this plane of the ecliptic, and all of the planets are from the side really close to being on that same plane. Everything is orbiting on that same plane or really close to it, as if we were all stuck on this phonograph record. Well, as the Earth goes around the sun, we are not straight up and down. That's not how the Earth is tilted. As we go around the sun, we are actually tilted about 23.5 degrees away from straight up and down. And it's that tilt that causes the seasons. Here's how this works. Now, the Earth is rotating on its own axis like a little top, but the top of the Earth is about 23.5 degrees off from that straight up and down line. And what that means is different times of the year, northern hemisphere where we live is tilted towards the sun, and some times of the year we are tilted away from the sun. When the Earth is tilted towards the sun, we get more direct heating and more direct sunlight. And when we are tilted away from the sun, the same amount of light from the sun is spread out over a much larger area. And we'll talk more about that in just a second. But basically it means we get more heat in our summer and more and less heat in our winter. So what about this direct heating concept? The sun is pretty stable. It gives off a set amount of light and heat that doesn't vary dramatically, but it does vary some. But as our sun emits light that hits the Earth, when we are tilted towards it, that sunlight is concentrated. If you think of it like water coming out of a hose, if it's concentrated in a smaller area that's hitting the Earth, it's stronger. The heating per square foot on planet Earth is much bigger during our summer. The same sun emitting the same amount of light in the winter, that light, as it hits planet Earth, is smeared out over a much larger surface area. So the light that in the summer was over a small surface area, in the winter is spread out over a bigger surface area. What that means is there is going to be less sunlight and heat per square foot of Earth or per square meter of Earth. And if there's less heat over a bigger area, that means we're just plain going to be colder. And in the summer, there's going to be more heat per square foot or square meter, and that means we are going to be hotter. The other thing that affects this temperature variation is the hours of sunlight. In the winter, there are actually less hours of light that hit our area in North America than in the summertime. As you might recall, if you go out to a holiday dinner on a winter evening, it might be dark by 5 p.m. That's easily happens in the northern part of the northern hemisphere. But in the summer, there's a lot more hours of daylight. What time does the sun go down in the summertime? I don't know, sometimes 9 p.m., sometimes even later than that. So that means that there are actually more hours of daylight hitting the planet, our portion of the planet. And again, this depends upon that tilt of the Earth. The opposite seasons occur in the northern and southern hemispheres. So in Wisconsin, in the wintertime, we are tilted away from the sun and we enjoy a Christmas that is very often white, and we build snowmen. Our comrades who live in Australia, in the southern hemisphere, Christmas is still for them December 25th, but their Christmas is in the middle of their summer, and so their snowmen might be sandmen, but they have the same types of seasons we do, but they happen to be flip-flopped, northern and southern hemisphere. So in our summer, in the northern hemisphere, when we're tilted towards the sun, southern hemisphere is tilted away from the sun, and it's going to be their winter. Our winter, we are tilted away, and the southern hemisphere is tilted towards, and they get summer. In between, there are two periods of time called the vernal and the autumnal equinox, and we'll talk more about equinoxes later. And a matter of fact, later has arrived. So that's going to end this video, and we will see you next time.